Hello friends, welcome to all of you. So today's topic is DFA for accepting numbers divisible by any number n. So in this video, we will discuss the general concept of making DFA for accepting numbers divisible by any number. I will take one value of n, and then I will show you how to create DFA for accepting numbers divisible by this number, and then you can apply the same logic for any number n. So we will start with n equal to 3. So I'm taking as n equal to 3, suppose. So friends, for creating such machines or DFA, you need to know how to create the number of states here. So like for n equal to 3, if we create or if we divide the number by 3, then what would be the possible number of reminders? What would be the possible values of reminder? So we can have 0 as reminder, we can have 1 as reminder, we can have 2 reminder, 2 as reminder. So that machine will be having only 3 states, only 3 states. So whatever number for any value of n, if we are creating the DFA, so we can have n minus 1 number, 0 to n minus 1 state there. So like for divisible by 3, we are having 0 to 2. That means 3 states. For divisible by 4, we can have 4 states. For divisible by 5, we can have 5 states. So in this way, in the same way, you can have these numbers, right? So now we will have here 3 states that would be representing state for remainder 0, state for remainder 1, state for remainder 2. Now you have to accept all the numbers divisible by 3. That means suppose this state is representing q0, and the name of the state is q0 I have assigned. Here it is q1 and here it is q2. That means all these states are, this represents q0 represents 0 remainder state, 1 represents 1 remainder state, and q2 represents 2 remainder states. Now as we have to accept all numbers divisible by 3, so we need to make this state as final state. We need to make this state as final state. One more thing, friends. See, if we are giving nothing, that means it epsilon we are giving, then it is also considered divisible by 3. It is also considered as divisible by 3. So that means we need to accept epsilon here. We need to accept epsilon here. That means our initial state should be the final state. There is one more reason to make q0 as final state. So that would be our final state. That's final. Now these two are non-final state. These two are non-final state. So what now? How we will proceed to make DFA for any except binary numbers divisible by 3? So first we can take this number here. First we can take any number that is divisible by 3, and then we can create transition from this state. So now let's take a number divisible by 3. So that would be 110. That would be 110. This is binary 110. And the decimal equivalent of this number is 6, and 6 is divisible by 3. 6 is divisible by 3. Now on this number we can apply only 2 digits. What? 0 and 1. And we are applying 0 on this number means we are adding one more 0 at the right hand side of this number. So if we apply 0 on this number, that means we are writing one 0 at the right hand side, it becomes 1100. 1100. That means it would be 12. It would be 12. That means 6 was divisible by 0. Sorry, this 6 was divisible by 3. And we apply 0 on this number. So we will have another number that is again divisible by 3. So we can have, on applying 0, we can have the same state here, right? Now again I can, on number 6 we are applying 1. On number 6 we are applying 1. So that means it is becoming 13. It is becoming 13. Now 13 is giving what number? 13 is giving remainder 1 after dividing by 3. So on applying 1, we will reach to this state, because it is getting, we are getting remainder 1. So we will move to state where it is representing with remainder 1. So on applying 1, we are reaching to Q1. Now we have considered both the input for, both possible inputs for state Q0. Now we will consider Q1 state, and we will try to get transition for both the input from Q1. Now, as this is the remainder 1 representing states, so we will take one number that gives remainder 1 after dividing by 3. So this is binary equivalent of this, sorry, decimal equivalent of this number is 7, and 7 gives remainder 1 when we divide it by 3. So we are taking this. Now to see the zero transition from this state, we will apply 0 here. We will apply 0 here. So after applying 0, after adding 1 0 here, it becomes 14. It becomes 14. And if we apply, if we divide 14 by 3, then it will give remainder as 2. So on applying 0 on this number, we will move to the number state where remainder 2 is represented. So on applying 0, we are getting remainder 2. Now again we are having the same number 7, and now we are applying 1 here. So now this becomes 15. Now this becomes 15, and 15 is divisible by 3. 15 is divisible by 3. That means it will go to the state where remainder is 0. So that means on applying 1 on this state, we will get Q0. We will get Q0 as new state. Now we have considered both the input for, both the transition for this state also. Now only this state we need to see the transition for both the symbols. So you can see, now we can take one example number that gives remainder 2 after on dividing by 3. On dividing by 3. So we can have 101. Decimal equivalent of this number is 5. And if we divide number 5 with by 3, so we will get remainder 2. So that's why I have taken this number. Now to see the 0 transition from this state, we will apply 0 here. Now it becomes 10. Now it becomes 10. After applying 0, it becomes 10. That means now what we will get the remainder again. So on dividing by 3, 10 gives remainder 1. So we will move to, on applying 0, we will move to remainder 1 state. Now on the same number 101, we are applying 1 now. We are applying 1 now. So now this becomes 11. This becomes 11. And if we divide 11 by 3, so we will get remainder 2. So that means we will, on applying 1 on this state, we will be there in the same state again. So now we have considered for both the inputs, both possible inputs for this. We have considered both possible inputs for this or for this also. That means this is our final DFA. This is our final DFA. And now, friends, you can check any binary number that is divisible by 3 that it will be accepted, otherwise all will be rejected. So I hope this would be very much clear. Now I will tell you one more generalized logic. Like here we are creating DFA for designing number divisible by 3. So we are making zero remainder state as final state. Now we are suppose we need to create DFA for accepting all binary numbers uh, uh, giving remainder 1 on dividing by 3. So we will create this Q1 state as final state. And if we want to accept the number, those are giving remainder 2 on dividing by 3. So we can create this state as final state. So these are the general logic. So you can apply these, and this is the DFA for accepting all binary numbers divisible by 3. I hope though, friends, it would be very much clear to all of you. Now we will see the same machine for decimal numbers also. In case of decimal numbers, we will have in place of possible inputs as 0 and 1 for binary, we will have 0 to 9 uh, in decimal. So that for that also we will create the machine. So friends, now we are ready to make DFA for accepting all decimal numbers divisible by number 3, divisible by 3. So now logic for number of states, same logic we will use. We will use one zero remainder state, one remainder state, and two remainder state. But instead of using two transitions, we will have now 10 transition from 0 to 9 for each input symbols. For this, what we can do now, we can have like in previous example also we have for checking for creating the transition from state Q0, we took one number that is already divisible by 3 and we applied zeros and ones there. So again, now as we are using decimal numbers here, so I can take 3 simply. So that is already divisible by 3. Now we will apply 0 to 9 one by one on this, and then we will see on what state we are moving. So now applying means at the right hand side of this we will create 0, 1, 2 up to 9. So first I'm writing 0. So 3 becomes 30. 3 becomes 30. That means on applying 0, we are getting the same state. It is also divisible by 3. It is also divisible by 3. So that means on 0, we are getting the same number. We are getting the same state. Right? Now, we will try to get 1. So now 31. If we divide 31 by 3, so it will give us remainder 1. So we can we are moving to 1. On giving 1, applying 1 here, we are moving to 1. Now we will apply 2. So now what we will do here, now you can see from here, if we apply 2, then it is giving remainder 2 on dividing by 3. So now on applying 2, we are moving to state Q2. 2. Now I will apply here 3. So now it becomes 33. 33 is again divisible by 3. So that means we are getting the same state. So instead of creating new transition, I will use this transition only. So on 0 applying, we are getting the same number, same state. On applying 3, we are getting the same state. Now, if we apply 4 here, so now you will get the remainder 1 state. So you can apply here 4. Then you can apply here 5 and you will get the this state, remainder 2 state. So I can write here also. Then if we apply 6, so you will get divisible by 3. So you will get the same state Q0. And if you apply 7 here, so you will get remainder 1, so you can get like this 147, and if you apply 8 here, so it will give it is 38 now, so it will give remainder 2, so you can write like this. And you now if you apply 9 here, so you will get 39, that is again divisible by 3, so you can have like this. So now we have seen all the transition for 10 different symbols from Q0. Now we will take one example number that is already decimal number that is already giving us the remainder 1, and then we will see the transition from this state to or this state for all input symbols. So I'm taking here as 4 because it is already giving remainder 1 on dividing by 3. So now we will apply here 0. So it becomes 40. Now on applying 0, we are moving to remainder, what remainder? Remainder 1 state. So on applying 0, we are here only. On applying 0, we are here only. Now if we apply 1, so it becomes 41, and now it is giving us remainder 1 state. Remainder 2 state. So remainder 2 state, that means on applying 1, we reach Q2. Now, so on applying 2, it becomes 42 and it is divisible by 3. So on applying 2, we are moving back to Q0. Now, on applying 3, it will gives us the remainder 1. So again we will stay on the same state. On applying 4, it will give the remainder 2. So I can write here 1 comma 4. On applying 5, it again becomes the number divisible by 3. So it will reach to Q0. Now on applying 6, it gives remainder 1. So I can write here like this. Now on applying 7, it will gives us remainder 2. So I can write like this. Now on applying 8, it becomes 48 and that is divisible by 3. So it will reach to Q0. And on applying 9, it becomes 49. That is again giving us the remainder 1. So it will, the self loop of 0, 3, 6, 9 will be on Q1, and we have seen all the transition for Q1. Now we will see the transition for Q2. So in order to take see the transition, we need to take one number that is already giving remainder 2 on dividing by 3. So we can take here 5. Now if we apply 0 here, it becomes 50. If we apply 0 here, it becomes 50. And 50 is again giving the same remainder. 50 is again giving the same remainder. So on applying 0, we will stay here only. Now, if we apply 1, then it becomes divisible by 3. It becomes divisible by 3. So we will move to Q0. Now, on applying 2, it becomes 52. So that gives us remainder 1. So on applying 2, we are reaching to Q1. On applying 3, we are getting 53 and it is giving us remainder 2. So we can be on the same state Q2. Then on applying 4, we have remainder 0. So we can write this, we will reach to Q0 on applying 4. Now on applying 5, we are getting remainder 1. So I can write here on this transition, I can write 2 comma 5. On applying 6, it gives us remainder 2. So we can make one more transition here. Now on applying 7, it becomes divisible by 3. So we will reach to Q0. On applying 8, it will gives us remainder 1. So we can write here on this transition, we can add one more symbol 8. And on applying 9, it will be giving us the remainder 2 only. So we can add one more symbol here like this. Now, for all the states, we have seen all the transitions. So this is our final DFA that accept all the decimal numbers divisible by 3. All decimal numbers divisible by 3. Now, I will show you one example. Like 33, sorry, uh, I can write 36. 36. 36 is divisible by 3. So let's see where we are having. So on applying 3 transition is there. So we remain on Q0. We are initially we are on Q0. On applying 3, we are still on Q0. On applying 6, we are still on Q0. That means after reading completing string, we are on Q0, which is final state, so it is accepted. Now we will take one example of any string that is not there. So we can take 72. That is again uh, divisible by 3. Again divisible by 3. So now take another example of divisible by 3. So you can see we are on Q0 and we read 7. So we read 7. So we reach to Q1 here. Now again on Q1 we read 2. So by applying this transition, we again move to Q0. And after reading complete input, we are on Q0, which is final state, so it is also accepted. Now we will take one example, 85. 85. 85 is not divisible by 3. So how we will be confirming this? So you can see we are on, initially we are on Q0 and we are reading 8. So you can see the transition of 8. So this is the transition of 8. So on Q0 we are getting 8, so we will reach to Q2. Now we are on Q2 and we are reading second symbol 5. We are on Q2 and we are reading second symbol 5. So on this transition we are 5 is there. So on applying 5 we can move to Q1. Q1, which is not final state. So this string will not be accepted. So this number will not be accepted. So you can check any number that is divisible by 3. It will be accepted by this machine, and those number are not divisible by 3. So they will not be accepted. So this is the general logic of creating DFA for accepting numbers divisible by any number n. And remember, we have discussed for binary numbers as well as for decimal numbers. So you can apply the same logic on for both the type of numbers. I hope it would be very much clear to you. If you have any doubt, you can write me in comments, and I will definitely reply your comments. Thank you. Thank you so much.